Hello everyone, this is Ashwini Dashgupta from Chinta.com. In this particular channel, we talk about mathematical Olympiads, science Olympiads, and everything that is related to non-routine problem solving and research. If you are interested in such content, please consider subscribing to our channel. And today, in that note, we will talk about a very interesting problem that came up in one of our AMC 10 and 12 review course. So as you know, we offer mathematical Olympiad programs. Check the link in the description for details. These programs have a ton of good problems. We learn a lot while solving these problems. I'm a big fan of learning stuff while solving problems. This problem is particularly really interesting. It came up in American Math Competition 10, and it says something very special about incenter, circumcenter, and the normal form of the sides of a triangle. So we will learn all that in this particular video, and while we learn that, we will solve that problem. Stay tuned and grab a pen and paper. Let's do this together, okay? So first I'll tell you what the problem says. It's a very simple statement. It says that there is a triangle. This is the given data. There is a triangle ABC with the side lengths 5, 12 and 13. Okay. Suppose I is the incenter and O is the circumcenter. So O is circumcenter and I is incenter. We have to find out the distance between O and I. So find OI. That's the goal. Okay. There are many things that are sort of intertwined in this particular problem. That's why I love it. The first thing is the use of Pythagorean triples. That's the first thing we learn. Pythagorean triples. Just by looking at these numbers 5, 12 and 13, if you are doing problem solving for quite some time, you will immediately recognize that this is a Pythagorean triple, which means they form a right triangle. So we have a right triangle like this, 5, 12 and 13. And why is that so? Well, you can easily check that 5 square plus 12 square equals to 13 square. 5 square is 25. 12 square is 144. That gives you 169. And it's all precisely fixed, sort of matches up. So this is a right triangle, which simplifies our life a lot. Because once it's a right triangle, we can secretly think about working in the coordinate plane. Things will become very easy. So here is a strategy. Work on coordinate plane. Okay. So how does that work? Well, just take the y-axis and the x-axis. Take this point as 5, 0. This point as 0, 12. And join it like so. And you have the required right angle triangle. Now what you want to do is to find out the circumcenter and the incenter of the right triangle. So the third thing, which we discussed in quite a bit of detail in our Math Olympiad program, is that circumcenter of a right triangle. This is very special. Circumcenter of the right triangle is actually at the midpoint of hypotenuse. It's at the midpoint of hypotenuse. So what is a circumcenter? Well, it's a point. It's a point from which you can draw a circle that passes through all the 3 vertices of the triangle. Centered at the circumcenter, you can draw a circle that passes through all the three vertices of the triangle. In the case of right triangle, it is super special. It is in the midpoint of the hypotenuse. One way to see this is if you draw any circle, if you draw the diameter of the circle, and you can draw any angle like this, ABC, then this angle at the semicircle is 90 degree. How can you prove that? Well, let's suppose this is the center O, the midpoint of the side opposite to 90 degree, which is hypotenuse. Remember, I told you midpoint of the hypotenuse is the circumcenter. Here, it is the diameter of the circle. So, you have to see the connections there. Okay, so you can actually prove this very easily. I'm not going to prove it to the last detail, but you should actually go ahead and prove that this is 90 degree. Actually, I am using the converse of this particular theorem, which says that the midpoint of the hypotenuse is the center of a circle that passes through all the three vertices. So with the hint that I gave you, can you in the comment section give me the final solution? Why is it so? Midpoint of the hypotenuse is the circumcenter. Well, if that is true, now you can use the midpoint formula to find out 5 by 2 divided 12 by 2, which is 5 by 2, 6, as the circumcenter of the triangle. All we need to find out is the incenter. Okay, to find out the incenter, you have to use the normal form of a triangle, sides. So what is the normal form? This is a very powerful technique. So this is number 4 thing we learn, normal form. So basically, if you have a triangle ABC, this angle bisectors of the triangle meet at a single point called the incenter. This is a very well-known theorem in plane geometry. Now what you do is you drop perpendiculars from the incenter on the three sides of the triangle. Turns out that these are equal, the length of these are equal, and they all pass through their feet pass through the same circle. So this circle is very special. This is called the incircle. This is called the incircle. So how is the incircle connected with the sides of the triangle? See, this point, these two are tangents from the point B. So the length of the tangent from an external point to a circle are equal, right? The two tangents are equal in length. So this is x, this is x, this is y, this is y, this is z, this is z. So the entire side lengths of the triangle are actually broken down into x, y and z, 3 pieces. That is called the normal form of the side lengths of the triangle. Here BC is x plus y, CA is y plus z, AB is x plus z. That means what we just showed is for any triangle ABC, the side lengths can be decomposed into x, y and z such that one of the side is x plus y, the other side is y plus z, the other side is z plus x. This is known as the normal form of the side lengths of the triangle. The normal form of the side lengths of the triangle. This is very important and very powerful stuff. Another way to write x, y and z is, notice that x plus y plus z is just 2 times the semi-perimeter, or it's just the 2 times x plus y plus z is the perimeter, or x plus y plus z is the perimeter by 2. which is the semi-perimeter. So you can easily find out x. X is simply semi-perimeter S minus the opposite side to the point B, right? S minus small b. This is also S minus small b. Similarly, this is S minus small c. This is S minus small c. This is S minus small a. This is S minus small a. Let's apply this in the context of the triangle, right triangle, okay? So in the case of a right triangle, we also have the incenter I, from which we can draw perpendiculars and we can create the incircle. Now this length and this length will be equal, and they will be equal to S minus the length of the hypotenuse, which is 13, right? S minus 13. Okay, what is S? S is the semi-perimeter. Semi-perimeter means 5 plus 12 plus 13 by 2, which is 15. So S minus 13 is 15 minus 13, which is 2. So in this particular triangle, this is 2, this is 2. So the coordinate of I is 2, 2. So now you know the coordinate of I, the incenter, and the coordinate of the circumcenter. The only thing that remains to be calculated is the distance between the incenter and the circumcenter. So you can use the distance formula. See how I reduce the entire thing into coordinate plane and use the normal form to find out the coordinate of incenter. It's pretty beautiful. So give me the final answer in the comment. It's very simple. Use the distance formula to find out the distance between these 2 points, and that will be your final answer. Give me the answer in the comment section. If you like videos like this, subscribe to our channel and stay in tune with mathematics. Keep on doing good work. I'll see you in the next video. Take care and goodbye.